Okay, so let's look at this function. F of x is equal to negative 1/3 x cubed plus 3/2 x squared plus 10x plus 3. Find any relative extrema for f of x. So the first thing that we need to do is find our derivative, and we need to find any critical points. So we need to set it equal to 0. So we're going to find f prime. So f prime of x, we get 3 times 1/3 is 1, so we get negative x squared plus 3x plus 10. We're going to go ahead and now set this equal to 0. I don't really like when I have my x squared being negative, so I'm going to change it. So I'm looking for something that multiplies to negative 10 and adds to negative 3. So we have x minus 2, x minus 5, and x plus 2. So we can set each of these equal to 0. This is going to give me x is equal to 5 and negative 2. So now what I'm going to do is make my table. So I have x values, I have f prime of x, and I have what's happening with f of x. So we care about negative 2, and we know our derivative is 0 there. We care about 5, and we know our derivative is 0 there. So I need a number less than negative 2, so I'm going to pick negative 3. We need a value that is in between. I'm going to make it easy on me and pick 0. And then I need something bigger than 5. So it doesn't matter what function we plug it into. Negative 3, I'm going to plug it into this equation right here. So we have a negative times negative 3 minus 5. So negative 3 minus 5 is going to be a negative. And we have negative 3 plus 2. Negative 3 plus 2 happens to also be a negative. So I have a negative times a negative, which gives me a negative. Because it doesn't matter what function we plug it in, I'm going to plug 0 into my original function for my derivative. If I do, this goes away, and we get a plus 10. This makes sense because I have a negative times 0 minus 5, it would be a negative. 0 plus 2 would be a positive. So negative times a negative times a positive. And then the last one we have here is 6. 6 plus 2 gives me a positive value. 6 minus 5 gives me a positive, and we have a negative. So a negative times a positive gives me a negative. So this is what we can see is kind of going on here. So I am decreasing, increasing, and then decreasing once again. So what I can see here that's happening is I'm going downwards and then I'm going upwards. So right here at this value, we're going to have a minimum. I then go upwards to then change downwards, so I'm going to have a maximum. One thing that I need to be clear about is when we look at this, just because I look at that one value, doesn't mean that a lot of things are happening at that value, specifically when we're talking about increasing versus decreasing. These maximums and minimums, though, do happen at those critical points, at those zeros. So I know for a fact the minimum is happening at negative 2 and the maximum is happening at 5. What I don't necessarily know is if it's an absolute max or min, because we're looking at an open interval, this interval between negative infinity and positive infinity. So one of the things that we're going to do now is plug in that value. So f of negative 2. I'm going to go ahead and plug it in. So we have negative 1/3 negative 2 cubed plus 3/2 times negative 2 squared plus 10 times negative 2 plus 3 If I do that, I get a really unfortunate, but not really that unfortunate fraction of 25 over 3. We're going to do the same thing, but for 5. So f of 5, negative 1/3 times 5 cubed plus 3/2 times 5 squared. It's 10 times 5 plus 3. I know I said the other one was weirdly unfortunate, but this one is 293 over 6. So we have a relative minimum at negative 2, negative 25 over 3, because f prime of x changes sign from negative to positive. At x equals negative 2. We're going to do the same thing, but instead of relative minimum, we're going to talk about it being a relative max, and we're going to flip-flop our negative and positive. So relative minima maximum at 5, 293/6, because f prime of x changes sign from positive to negative at x equals 5. Okay. Let g prime of x equal 3x squared times x plus 5 times x minus 5. Find the interval where it is increasing or decreasing, and find the location of any relative extrema. So same kind of thing, we are going to set the derivative equal to 0 to find our critical points. So 0 is equal to 3x squared times x plus 4 times x minus 5. So 0 is equal to 3x squared, 0 is equal to x plus 4, 0 is equal to x minus 5. So x is going to equal 0, negative 4, and 5. So now we can go ahead and make our table. So we have g of x, g prime of x, and x. So I know I need to look at negative 4, I know I need to look at 0, and I know I need to look at 5. I also need to look at values around those values. But I know those values are 0. So a number before negative 4 could be negative 5. A number between negative 4 and 0, I'm going to say negative 1. After 0 but before 5 is 1, and after 5 can be 6. So we're going to plug all of these numbers into our factored version and see what happens. So if I plug in negative 5, negative 5 squared is going to be positive. No matter what I put into this first part is positive. So this part doesn't necessarily matter, so we're going to really focus on these two. Negative 5 plus 4 is going to be a negative. Negative 5 minus 5 is a negative. Negative times a negative is going to give me positive. We have negative 1. So we know the first part's positive. Negative 1 plus 4 is positive. Negative 1 minus 5 is negative. Positive times a negative is a negative. 1 plus 4 is positive, 1 minus 5 is a negative, positive times a negative is a negative, and if I plug in 6, 6 plus 4 is positive, 6 minus 5 is positive, so everything in there is going to be positive. So when we're looking at this, we have an increase, a decrease, more decrease, and then an increase. So we are increasing, so g of x is increasing when x is less than negative 4. You can say less than or equal to. And x is greater than 5. G of x is decreasing when x is between negative 4 and 5. So one thing that we sometimes can forget but have to be careful about is our because. So why? So this is because g of x has, or g prime of x is positive, and this one is because g prime of x is negative. Okay, so when we look here, this first piece here, it's increasing to decreasing, so I know this goes up before it goes down, so a maximum. We have a decreasing to increasing, so this is a minimum. This one right here, we are decreasing, it flattens out for a second, but then we decrease more. So it's not a maximum or a minimum. So we have a relative maximum at negative 4 for x, so g of negative 4 is our relative max. Because g prime of x changes from positive to negative. Similarly, g of 5 is our relative minimum because g prime of x changes from negative to positive. So we just need to be careful about our reasonings, but we have a lot of the similar things that we were doing for increasing and decreasing, and now we're just adding one piece in there. Okay, we have a 2017 AP example. The graph of f prime, the derivative of f is shown above. On what interval are we increasing? So we have to keep in mind that we have the derivative. So this is already telling us when it's positive or negative. So we are looking at anything above this line being increasing and anything below it decreasing. So one of the things that I do first a lot of time is just remind myself increasing, decreasing. Okay. On what intervals is f increasing? Justify our answer. So we are increasing from negative 6 to negative 2. And we are increasing on 2 to 5. And that's because f prime of x is positive on these intervals. Find any values where f has a relative minimum. So we need to think about what we're looking for. Relative minimum happens when we are going from decreasing to increasing. So we need to go from below the x-axis to above the x-axis. So if we look here, we are decreasing, now we are increasing. So this point in between those two, right here, is where that happens. So f of 2 is a relative minimum because f prime of x changes sign from negative to positive at x equals 2. Our last one here is another AP style problem from an AP exam. So 2015 AP exam, the graph of f prime, the derivative of f is shown above. So once again, we have the derivative of f. So I know if it's above, it's increasing. If it's below, it's decreasing. Find all coordinates in which f has a relative maximum. So a relative maximum is when we go from increasing to decreasing. So if we look here, when we are above to when we are below, that happens right here at negative 2. So f of negative 2 is a relative max. And that's because f prime of x changes sign from positive to negative at x equals negative 2. What are the critical values of f in the open interval negative 3 to 4? So critical values is anytime our derivative is equal to 0. So if we're looking at this, this is the graph of our derivative. So when does it equal 0? When it's on the x-axis. So our critical values has critical values at negative 2, 1, and 4, but we need to remember we're on the open interval. So we are not looking at 4, we're looking near 4. So x equals negative 2 and 1. It doesn't say why, but it's because f prime of x equals 0. On what open intervals is f decreasing? So we're decreasing when we are below this x-axis. So anything between negative 2 and 4. So f of x is decreasing on the interval of negative 2 to 4 because f prime of x is less than 0. So we're just realistically adding one more layer to what we were doing before.